Hey guys, welcome to question MM154 of the Maths Methods Fortify study guide. Now we've got this question: for the curve y equals 3 take x squared, the tangent to the curve will be parallel to the line connecting the y-intercept and the positive x-intercept when x is equal to what? So this is our graph of 3 take x squared. If you're not sure what this looks like straight off the bat, just chuck it in your CAS. But if I were you, if you're not too sure about this, please try and get familiar with it because quadratics is really, really important during your year 12. But for now, this is our graph. We know that there's a line connecting the y-intercept here and the positive x-intercept here. So we've got this line that goes between here, and we know that the tangent to the curve will be parallel to that line, right? So the tangent to this line here will go up like this, and it's actually going to be parallel to this dotted line here connecting these 2 points. So first of all, we need to work out what the gradient of this line is, because we're not going to be able to work out where the x value is if we don't know what the gradient is. So if it's parallel to this dotted line, that means that it has the same gradient as this dotted line. So we need to work out what these 2 points are. So we know that this is the y-intercept of our function. Now our y-intercept occurs when x equals 0, which means we have y equals 3 take 0 squared, which is simply just 3. So that means that our y-intercept is 0, 3. So that's our point there. Now we need to work out what our x-intercept on the positive side is. So our x-intercept happens when y equals 0, which means that 0 is equal to 3 take x squared is equal to 3, which means that x is equal to plus minus square root 3. Because this is on the positive side, we know that this is our positive root 3. Root 3 is 0. Sorry, my marker's gone a bit weird. And this would be your negative root 3. But we're looking for the positive version because it tells us that in the question. So we know that the gradient between these two lines is the same as the tangent, which means that we need to work out the gradient of that dotted line. How do we work out gradient? y2 minus y1 over x2 minus x1. So we've got our 2 points. Let's say that our first point is our y-intercept, which means that y2 is equal to 3 minus 0, because our x-intercept is our second point. x2 is equal to 0, and our x1 is equal to root 3, so minus root 3, which gives us 3 over negative root 3, which is equal to negative root 3. So we know that the gradient of this line, this dotted line, is negative root 3, and it's parallel to the tangent, which means that the tangent also has a gradient of negative root 3. Cool. To work out the gradient of a tangent to a curve, we need to differentiate the original function. So we know that y is equal to 3 take x squared. Our differentiated version is negative 2x, right? Because we take this 2 down to the front and minus 1 off the power. This is the x value that we're looking for. We know that the gradient is equal to negative root 3 because we've just worked that out, which means that negative root 3 is equal to our gradient function, which is negative 2x. So from here we just rearrange and we end up getting x is equal to root 3 over 2, which tells us that our answer is A. Guys, if you got confused by anything in this, please let me know in the comments below. But yeah, that's it. Really just try and work out what you need to find in terms of the gradient and how the parallel nature of these lines affects all that. And then you'll be able to kind of work it out from there. So guys, have a great day and keep working through those questions.